Most people think of planets as massive objects orbiting a star in the solar system, but what if I told you that it's more common for a planet to roam interstellar space completely alone with no star at all? These objects are called free-floating planets, but for the remainder of this video I'll be calling them by their other name, rogue planets, since it's a lot less of a mouthful. Rogue planets are planets that don't orbit a star, and instead occupy the lonely space that exists between solar systems, or even lonelier, between galaxies. Research from NASA and Osaka University suggests that there are more rogue planets than star-orbiting ones in our galaxy. Just for reference, there's an estimated ratio of 20 rogue planets per one star out of 100 to 400 billion in the Milky Way. This comes out to around 5 trillion of these planets being relatively close to us. There are two main ways that rogue planets form. One of these ways is by the collapse of hydrogen clouds which weren't massive enough to produce a star. This creates a gas planet called a sub-brown dwarf, which is just a really horrible name in and of itself. You can kind of tell it's a boring planet. You can also call them brown dwarfs of planetary mass, but that's really, really long. The other more interesting way that rogue planets can form is being ejected from young solar systems when the interaction between objects is more chaotic, meaning a planet is more likely to be flung out of orbit by another object. These ejected planets are often rocky and similar in mass and terrain to Earth. Planets are more likely to be ejected from binary star systems than single star systems. This is because of multiple things. For example, binary star systems can create regions of instability where the gravitational forces of two stars compete with each other. This means any planet entering this region could be ejected from the solar system. This is called the dynamic instability limit. Another reason is planet-planet scattering, where gravitational interactions between planets can destabilize orbits and lead to planets being ejected. This can also happen in single star systems, but it's less common. Ejection can also be caused by close encounters with other stars, stellar flybys, which can disturb planetary orbits and lead to ejection. Rogue planets can be detected with their own light in the case of young sub-brown dwarfs, while they still have enough energy. However, for terrestrial rogue planets which have no light of their own, another technique is used, which is the use of gravitational microlensing. This is when a rogue planet passes closely in front of a star that's distant from us. The gravity of the planet causes space to warp, bending the light and magnifying it to produce an image like this. Wow! Here's a video of how gravitational microlensing works. Now this bit is just about us, so I don't actually have a script for this bit, so forgive me if I go off piste. But there's a chance that there's life on these rogue planets if they have moons, because of the tidal forces. It can like squeeze and like stretch the planet or like compress it, and that gives the planet energy and like heat through friction. So if there's geothermal vents and the planet is geologically active and like, you know, there's like magma and stuff moving around, then, you know, they can like the stuff, minerals comes out of the geothermal vents, which is very similar to how life formed on Earth. And since these planets are like really, really cold, and they've got like, since there's no star that they orbit to give them energy, they have like this thick layer of ice on the outside, which is great because it protects from impacts like asteroids and like radiation and stuff. So these whatever organisms could be there, they could be living their best life. But this is in the case of the water planets, not the terrestrial ones, but who knows, I'll give you something to think about. Hope you enjoyed my video.